Good morning, everybody. Today is Tuesday, August 2nd, 2022. It is the Podman community meeting. This meeting, oops, if I can get the right mouse going here. It's an ongoing meeting on the first Tuesday of even numbered months. It says of the month, but it's even numbered months. We may move it for timing to be a little friendlier for our folks in India, China, and Australia. Topics are driven from prior meetings or from requests to me directly, so always happy to take more topics. Discussions will be accepted for anything that's related to containers, including Podman, Builda, Scopio, and any of the container projects, or even stuff that just slightly touches it. We're always happy to discuss all kinds of different things. Meeting notes I will be taking care of during the meeting. If you have links, especially for the presenters, that might be helpful to other people, I would appreciate it if you could dump them into the PackMD as we go along. And if you see that I've captured something inappropriately or just off a bit, please go ahead and correct me. I'm very happy to have multiple note takers on in there. So today we have a couple of great demos coming in. We have a Fetchit demo from Sally O'Malley and Ryan Cook. They'll be tag teaming that. And then Urvashi Mahani will be moving pods and containers to Kubernetes cluster using the Podman play cube. I can speak English some days, but not often, command. And then our next meeting will be on Tuesday, October 4th at 11 a.m. again. And so that's all we have there. So I'm going to stop sharing. And I'm not sure, I think, Ryan, are you starting out first?
Yes, I am. I will be
Okay, Ryan, go ahead and take it away.
Oh, all right. Let me get these slides up real quick. And I promise we have demonstration bits. So it's not just slides the whole time. So as said earlier, we're going to talk about the project Fetchit and kind of how we got to the story around Fetchit. It was around the idea that managing containers at scale was kind of difficult. There wasn't really any tools to have like a very, very nice experience, similar to what you see with Kubernetes and Argo CD. The tooling that you can manage Podman containers and lifecycle them, it's not really Podman specific. You were just kind of forced to use the tools out there. So that's when we kind of came up and began to develop the idea around Fetchit. So, kind of why Fetchit? What is Fetchit? So Fetchit uses the GitOps methodology to allow for the lifecycle of a container to be managed by a Git repository. With that, what that actually means is that Fetchit runs in a container on your system. And then from there, based on a schedule, it's going to go ahead and check your Git repository and then launch subsequent containers that it sees in the Git repository. So the nice part about that is that there's no intermediary in play. You don't have to launch an Ansible playbook to go and reach out or run locally. It's just going to go and talk to the Git repository and operate from there. We were very spoiled with the fact that the Podman Go bindings existed, allowing us to do a lot of the difficult things, such as creating containers using the kube play functionality. So we get the piggyback off that really nice functionality that was developed. The other thing about this is we're not Kubernetes dependent. So if you have an environment that just runs containers, this is like right up your alley. And the last part about it is the ability to lift and shift hardware. And what this kind of means is the fact that I can put the Fetchit service on a container and throw it out into production, plug it into a network port, and we're actually able to manage the lifecycle of containers. So as I mentioned earlier, how does Fetchit actually happen? We pull in assets from Git, and we pull in images. Those can be from a USB device or from GitHub, GitLab, etc. We operate on a cron-based schedule. How this kind of works is you say, I would like to run the Fetchit process every minute, every 5 minutes, based on what your kind of business needs are. Or if your organization operates on, back in the old days, a lot of companies would have a maintenance window between 12 a.m. and 2 a.m. You could actually use that kind of cron-based scheduling to only update during that maintenance window. We launch containers and kind of manage the lifecycle using the Podman sockets. And the nice part about this is the fact that we can use both the user socket or the root socket. So for security reasons, we don't have to be root to be able to launch containers or run Fetchit. And then the last item I want to kind of bring up was the dynamic reload of Fetchit configuration. Sally's actually going to show a config file later in a demo. But the gist of this means that if for some situation that you need to update the definitions of the containers running in your environment, you can update the file, the configuration file within your repository in one place, and that will get distributed down to all the systems running Fetchit. So with that, I'm going to go ahead to pass to Sally to talk about the various methods that we have to run with Fetchit.
Sure. And yeah, like Ryan was saying, I think of Fetchit as solving this use case for like resource constrained or unreliable connectivity, devices only running a few pods or containers. I believe that's where Fetchit fits in because, above that, Kubernetes has solved many of these problems for anything above that. So here, Fetchit has a list of different methods that it knows about. And they are, well, first of all, the Fetchit binary, it runs in a container with a Podman volume. Usually I run it as a systemd service, and it mounts the Podman socket. Containers spin up and perform work depending on which methods are configured. And so these methods include, you might manage a simple raw pod definition or a systemd service, you might want to run an Ansible playbook or a file transfer from a Git repository to somewhere specific on your host. Those are the methods that Fetchit knows about, as well as some other non-Git target methods like prune, which we'll show later, but runs podman prune, a config reload target, and the other one, I'm sure it'll come up, missing one. But yeah, it's all about the remote hands-off management of workloads and with only access to Git. So it can be GitHub, a private Git server, or flash drive with Git content plugged in. You don't need SSH, you don't need the IP address. Each machine has its own config and Fetchit runs accordingly. So what's the next slide? Yeah, there's a few ways to trigger this config reload. They both include grabbing the updates from a config URL, just the content in a URL. So you can either specify it in your Fetchit config file, or you can set in the Fetchit container, you can set an environment variable that is Fetchit config URL. So with either of these, Fetchit will periodically check for updates. If it finds an update, it will reload the targets and carry on. And the prune method. We use the Podman prune function. We included it with Fetchit because oftentimes you're updating images, you end up with a lot of cruft, a lot of stale images, containers. So if you just stick this in the top of your config file on a schedule, Podman prune will run. And things coming up in the future. Go ahead, Ryan.
Yeah, I was just going to jump in and just cover this one, and then I think we're up to demos right after this. So
Cool.
Actually, Sally, why don't you go ahead and talk about GetSign and the image
Sure.
verification?
Yeah, GetSign is a pretty cool new project out of SigStore. You can try it out if you just go to sigstore/GetSign. But I've been playing around with it, and I'm going to add. We're kind of ahead of the game, like nobody's really using it yet, but eventually this is going to become very important. And you can tell with how we're using Git, we're going to need some way to verify that the commit is what you think it is. And so we'll add the commit verification using GetSign as a new feature coming up. And then Ryan, you want to talk about the image verifications? Same thing though.
Yeah, exactly. So as everybody pretty much knows, a big thing based out of the Project SigStore is the cosign functionality. And that functionality allows you to sign images and verify that they have not been kind of tampered with along the way to your system. So we'd like to include this functionality, especially as that supply chain security is becoming even more important. So we'll have some sort of functionality of image verification in the future. So these are two huge security topics that I think that we'll be able to cover to help make everybody feel a little safer at the end of the day. And then the last item we're going to cover here is the Ansible pull method. I know on the previous slide, we saw the Ansible functionality as it exists today. How that works is Ansible pulls down, Fetchit pulls down the Git items, and then Ansible runs the playbook. Ansible pull functionality exists to allow for Ansible to do the heavy lifting of grabbing the repository and deploying the assets. Right now, this functionality is usually handled on a system via putting it in cron. So we'd like to actually just get that better into a more efficient method. So
Yeah.
for demonstrations.
I just wanted to point out on your image, on the previous slide.
Yep, let me try to figure out how to get back. There we go. Yep.
So in image verification, Podman is building into itself basically what is you're calling cosign verification. So it should be. I don't think you're going to have to do anything. Podman's going to grow this ability, and
Yes.
it just has to configure the. You got to configure the Podman configuration file to say basically what we trust, and then we'll verify against the SigStore signature. We try not to use the cosign word anymore because it's not going to be full cosign support. It's going to be SigStore support. But
Awesome.
for interrupting.
Yeah, 4.2.
Perfect.
Less work for us.
Exactly. That makes me really appreciate using the Go bindings that y'all have produced and allow us to use. So, all right, so we're going to have 3 demonstrations. The first up is kind of a scale out scenario where we're going to kind of deploy a bunch of servers at the same time using user data to show the process of I have a scratch system and now it's fully configured. The next is after that, we're going to show the Podman Cube functionality.
We're gonna flip the order. We're gonna do systemd first, then Podman Cube.
Cool. Okay. So yeah, we're gonna show Fetchit deploying systemd based assets, and then flip that around. Finally, we'll wrap up with Cube and then the cleanup functionality. And as Sally mentioned earlier, the cleanup functionality is huge, especially in those weird small scenarios where you don't have a ton of disk space and you're rotating that image frequently. You know, you're not going to run into situations where you're just filling up the disk and having a bad time. So let's jump straight into the demonstration. I'm hoping this is coming through clearly. You guys are seeing a shell. Perfect. Okay. So what you're seeing here is a cloud init or user data for launching a server. The big things to point out here are we're just installing Podman, we're enabling the Podman socket, and we are grabbing the systemd file for Fetchit. That's pretty much all we need. As Sally had mentioned earlier, we're providing a Fetchit config URL. And what this does is that's a configuration reload file that says, hey, every 2 minutes check in, but these are the assets that I'd like you to deploy based out of the examples raw folder. And we're going to check and try to deploy those every 2 minutes. So here on Amazon, we're going to launch a RHEL 8 instance. And we're going to keep this kind of tiny. It's going to be 1 vCPU and 1 gig of memory. So, you know, that could be the equivalent of your Raspberry Pi out in the field, or just an old server or an old system that you have sitting in your desk that you want to just maintain the life cycle of some containers with. So just hitting the various items here within AWS, we're going to paste in that user data that we saw earlier, showing the installation of Podman, enabling the Podman socket, and starting Fetchit. And now we're actually going to launch 10 instances at once. And so pretty much what we're doing is we're just using the user data to go ahead and instantiate the Fetchit functionality and deploy our application. So this is like the infrastructure as code, thoughts from a few years ago. So now you see we have various systems. They've been up for about 4 minutes. There's 10 of them. And you see all of our containers have automatically started on the system. We actually didn't even really need to touch those systems. So taking a look at all 10 of our web pages, we have this cool blue web page. So to show the functionality of Fetchit, what we're going to do right now is we're going to modify that examples raw directory that we saw earlier. We're going to change the color to pink for the application. We're going to go ahead and commit that to our repository. for the specific branch that we're using for Fetchit. So we're pushing those assets to the demo branch. So as you see here, Fetchit was waiting for something to actually happen the whole time. And after the next run of the cron, we see that there is a change to that caller1 JSON. So we're going to check to see if that image exists already on the system to save us some time. And we're going to refresh and deploy that new callers container based off our updated environment variable. So now when we're going across all the pages, you see this amazingly bright pink color, letting us know that Fetchit has life-cycled all 10 of those systems. And the best part about it is we did not have to actually manually touch these systems. Fetchit just did all of the hard work for us. And so with that, I'm going to go ahead and pass over to Sally for some system.
Sure. I've squashed 2 demos into the time of 1, so let's see how it goes. Do you see my first demo here? It looks like a shell, and I'll try to increase.
It does not look like the screen sharing's coming in yet.
Is it good?
It is not showing yet.
Oh, okay, hold on. What did I do? It says I'm sharing.
There we go. Yep.
Okay, cool. Let me go back. So here, the first demo is going to show the systemd method with a config reload target. It's running Fetchit as a user service as non-root, and there's a single get target, a single systemd method, and also a config reload target. So I'm going to fast forward through. So here is the unit file running Fetchit. I think Ryan showed it. One thing I want to point out is it's Podman generated. The Fetchit volume's mounted at opt in the container. The config file's mounted at opt mount in the container. The Podman user socket is mounted in the root Podman socket in the container. So Ryan showed running as root. I'm showing running as non-root. And a sort of tricky thing is if you're running systemd as non-root, Fetchit needs to know, the Fetchit systemd container needs to know where this xdg runtime dir is. So you kind of have to trick it and tell it that it's the user xdg runtime dir inside the container, because inside the container is actually the root user running Fetchit. So here is the Fetchit config that's running. Again, it's a config reload target and a single get target. So when it starts, you'll see that the config is reloaded and will show this extra right here. It will add a method for file transfer. Starts out with just the systemd method though. Going back, it all happens fast, so I gotta kind of explain it before it happens. So here we'll start Fetchit and look at the logs. There we go. Fetchit's running as a systemd service. Here are the logs from that container. The get target was fetched, config is updated, the backup config was placed, new targets are loaded, and for each method, what happens is containers spin up, perform the necessary work, and then they go away. In this case, a container handles copying the HTTPD unit file to the correct host location, which is etc systemd, or in this case, config systemd user. Then a second container spins up and handles the enabling of that service on the host. So now that the service is enabled and the files are loaded, Fetchit calms down. There are no more changes to process. And you can see on the host that the HTTPD service is running, and on the host, the files are on the host. So now let's watch the logs as we update the image in the HTTP unit file. So I'm going to change the image from the HTTPD 24 to my example image. I made the change, I'm pushing to GitHub, and let's just watch the logs. So here you can see that the new commits processed for each method. So there's no change to the files for the file transfer method. So that commit does nothing with this that method does nothing with this new commit. It just does nothing. But there is a change in the unit file. So you see that the containers spin up to process that change and then restart the HTTPD service. And if I was to look at the service, you'd see that it's now running the updated image. So in the interest of time, this is a very abbreviated version. There's the new image. But it did show that Fetchit runs as a user service. It enables a systemd service from a unit file stored in Git, dynamically adds new targets from a config served at a URL. This is all done as a regular user, but you can also run it as the root user. So moving on to demo number 2, and hopefully we'll have time for questions after. This next demo is also very quick. So here is a demo from our amazing, I don't even want to call him an intern because he's just the most amazing intern. He made this video for the Fetchit kube play method along with the clean method. So here, the kube play method will look for YAML files. In this example, there's a persistent volume claim YAML, and there's also a pod YAML. So these are stored in a Git repo. Fetch is going to grab them. Down below, you see the run command. It's really similar to what we showed in the unit files, just that Joseph is running this as a standalone Podman command. And here are the logs. Down below, you'll see that Fetchit's running. It's processing the kube method and the clean method. Already it has pruned some DAL images, and it has started the Nginx 121 container. What happens when we switch the image from 121 to 122? If you look, there we go. If you look at the top screen, you'll see Nginx 121 switching to 122. We're going to push that change and watch it process. And that will be at 3:08. So you can see that the new commit was grabbed. The new container was started with Nginx 22. And lastly, the 121 image is still on the host. But, well, you can see, if you look below, you can see that Nginx is now running with 122 and not 121. You can't really see it there. But here you can see that both images are living on the host right now. As soon as on the schedule, the prune will run and that 121 image will disappear. So that hopefully showed the kube play method in a fast way along with the clean method.
So
These videos we'll share on YouTube so you can watch the entire versions. Any questions? And do we have time?
I'm just going to post this up here as where's the code for everybody to take a look. And I encourage everybody to file issues against whatever possibly in the world they'd like to see against it, or hope there shouldn't be any bugs. I feel like we have a great testing framework, but if there's anything you all want to see.
Let me just mention that. Yes, if you want to see all of the function of Fetchit, you just look in our repo at the examples directory, and every time we've added a new feature, we add a workflow for that and test it all through GitHub Actions. So we've done a really good job at that. So every single thing Fetchit does is in one of those YAML files.
I have maybe a quick question.
Mm-hmm.
If you, in your configuration, if you remove a section, will it, and say that had containers and volumes and stuff associated with it, will it shut those containers down when it updates it?
That is a really good question. We do a little bit of that, not completely, and we can add more as we go. But if you remove a file that Fetchit is watching, it will go and delete it off the system. But yeah, Ryan, you can explain it better.
Yeah, so
What do we do?
with the raw method, and I believe the cube one is still somewhat in development, but I think it cleans stuff up enough. What happens is we do the latest git pull and we see if the file has been removed from the repository. So if you remove the container definition, we will attempt to run kind of a container removal against that container. The one thing that I will say is, I know for the raw method, since it's so simple, we wipe out the asset, the container itself. I think one of the things we'd like to call out here is the prune method of why that's important, because that dangling volume would then get picked up by the prune method. Once that container goes away, then we would use the prune method to take care of it as well. So as you see these, we have to kind of do Legos of putting all of these things together to kind of help each other out.
Yeah, but in the case of like a systemd service, Fetchit doesn't know how to stop a service that it started. And it also doesn't check that the service is running with every run. It could, but we always have to be careful we're not reinventing Kubernetes or we're not reinventing Ansible, so we're always kind of watching out for that, but that's absolutely something that would be easy to do if we want to.
Yeah, I would say that if I remove a systemd unit file, you should shut it down and disable it.
Yeah.
If I created it and then removed it.
Yep.
If you could track that. And similar what you're doing with the kube play stuff to do a play down.
Yeah, we will add an issue for that. That's something that has been on our minds, but not exactly an issue yet. So we'll add it.
Yeah.
So I guess on a related thing, since
before we go on, we're running really tight on the clock. I'd like to stop the questions on this for now because we do have 2 other topics yet, and we're 15 minutes past time. But it's been great. If we have more time, we'll go ahead and get back into the discussion afterwards, please. And with that,
perhaps we want to pull this to a Cabal meeting in the future. As opposed to a community meeting.
Yep, that sounds good too. All right, so next up we have Urvashi talking about moving pods and containers to Kubernetes clusters with Podman Kube Apply.
Yeah, thanks, Tom. Let me just share my screen. Hopefully you can see that fine.
Yes, that looks good.
Okay. All right. So today I'm going to talk about the new command that we're adding called Podman Kube Apply. So at Podman, we already have the generate kube command that lets you generate kube YAMLs from your Podman pods and containers, volumes, etc. So we're adding a new command called kube apply, which lets you directly deploy the generated YAMLs to a Kubernetes cluster. So for this demo today, the first thing I'm doing is I'm setting my kubeconfig environment variable to point to my kubeconfig file. And for this one, I'm using an OpenShift cluster. It will also work with a plain vanilla Kubernetes cluster as long as you have a kubeconfig file. So as you can see here on the cluster, I'm just seeing if I have any pods created in the default namespace, and so far I have none. With Podman, I have already created a simple pod called my pod. It just has a simple Alpine container in it running. So this is just the help menu for the kube apply command. So as you can see, we have 3 flags here. It lets you set the path for the kubeconfig if you don't want to use the kubeconfig environment variable. You can also set the namespace of where you want to deploy your kube YAML. If you don't set this, it will deploy to the default namespace. And we also have the save cert file flag. In case that your kubeconfig file doesn't have the save cert data in there, you can point it to another cert file. If you don't have a CA-cert file, you can also set it to insecure, and it will skip the verification and run your connection as insecure. All right, so there are 2 ways to kind of run the kube apply function. So you can just pipe the YAML that's generated from Podman generate kube and just pipe that into the kube apply command as being done here. So as you can see, that went through, it was successful. Now let's go on the cluster and see if the pod was deployed, and we can see that the pod called my pod is up and running. I also have a bunch of containers I have created here. One of them uses a volume, so I have a volume created with Podman as well. So I'm going to generate a kube YAML that has the PVC definition for this volume as well as the definition for the container. But this time I'm going to save it to a file with the -f flag that generate cube lets you do. So I'm just going to call that vol.yaml. That's generated. Now let's take a look at the YAML file to ensure that everything looks good. As you can see here, I have my PVC definition, and then as I scroll down here, I have the pod definition as well from the container that I generated from. Same thing again, just the podman cube apply function and pass in the YAML file that was generated. Oh, and I'm just going to show that you can also use a kubeconfig flag to point to your kubeconfig file if you don't have the environment variable set. But the environment variable is very, it's easy to have because that's what you use for your Kubernetes or OpenShift cluster anyways. So as you can see on the cluster, I did get PVC. So my PVC was created, so the same name PVC test. And then the pod for that called vol test3 pod now was created as well. All right, so I'm going to create a new namespace or project on the cluster called bar, and now I'm actually going to deploy my generated YAML to that namespace instead of the default namespace. So here I'm going to use the test port container that I have over here because I have set some ports for it. So I will generate a service file for that as well with the -s flag, and just pipe that through to the kube apply command. And set the namespace to bar here so that it gets deployed to the bar namespace and not default. And then let's take a look at the services on the cluster in that namespace. The test port pod service was created, and then the pod for that was also created on that in that namespace. So just a quick kind of background of what's happening underneath. Basically, we are parsing the kubeconfig file that we get to grab the CA-cert data, the client certificate and key data, and the server address. That's your cluster endpoint. And we're not using any of the Go like Kubernetes APIs. We're not vendoring anything from Kubernetes, and we're using the pure HTTP API endpoints in an effort to preserve the Podman binary size and not increase it by vendoring a lot of files in. So for now, we are only supporting the kinds that Podman generate support. So that is pod, volume, container, service. But we can definitely extend this in future to add other kinds as we add more support for it to our kube commands. That's all I had for the demo. If there are any questions, I can answer that.
During the demo, you showed one time you used the config file when you did kube apply, and the second time you didn't. Is there a reason for that?
Oh, no, I was just showing that. So with the kubeconfig flag, you can pass in the path, but if you don't want to keep typing that all the time, you can just set the kubeconfig environment variable in your environment, and it will automatically pick that up.
Should we have a location where, like, the default Podman config file would be read from?
No, because when you're using a Kubernetes cluster anyways, you always set that kubeconfig environment variable so that when we do kubectl get pods or oc get pods, it knows which kubeconfig file to use.
All right, so that's standard protect.
So that's standard, yeah, that's standard process, yeah.
Okay.
Yeah. One more thing is that your kubeconfig file can hold information from multiple clusters, but usually I think what we are kind of just using the first cluster information that's in the kubeconfig file. So that is the first entry there. And that's usually the one that is, I think, the standard one to be used. But there is a possibility to have multiple cluster configuration in one kubeconfig file.
Is that did you hand create the kubeconfig file, or was that generated by OC?
It gets generated when you create your cluster, either with Kubernetes or with OpenShift.
But if I had a cluster that's up and running, say, and OpenShift online,
yeah,
how would I create the kubeconfig for that case?
So I don't know about OpenShift online, but when I have just created a vanilla Kubernetes cluster as well, it creates the kubeconfig for you and tells you where it has saved it, so you know where to access it from.
Yeah, I guess I'm asking, should we have that built into Podman 2 to create that file?
No, I don't think so. That comes when you create your cluster. There's nothing Podman can do for that.
It's usually provided by when you get access to a cluster, or like when we are creating a cluster using kube or some other tool, it automatically generates a config file. So I
Right.
believe like
We're trying to eliminate the need to have kube config on your machine. I mean, any other Kubernetes command on the machine, right?
No,
so,
but
so
like,
one,
yeah, go ahead, Adi.
So one thing which this is my like personal opinion, people would in the end want to eliminate the states where a thing from Podman is directly going to cluster without any state of commitment in between. So because that creates a lot of inconsistency in production when you're running a cluster in production. So for example, if I have a cluster of n number of nodes and the workload is directly going from Podman to a cluster, and there is no state of declaration of the cluster, I'm talking both about the workload of the Podman and the configuration of the cluster, then it would be hard to manage that on a production scale, as far as I can see. If this is just a playground tool, then I think it would be fine. Otherwise, the config and both the workload, which is being migrated from Podman to Kubernetes, has to be committed before moving.
Yeah, I'm just saying that it just so happens I have Florent on my screen here, and I think Podman Desktop would be a use case where you have a developer, he's developing a series of containers and pods, and all of a sudden he wants to try it out inside of his Kubernetes cluster. So I think that's the use case we're really, in my mind, that's the use case we're trying to enable here, is that developer would be able to launch it. But Tom just came on my screen. He's about to yell at me to stop talking, so we can move on to the next subject. But
Not quite
we
yet.
can
I
cover
did
this
want to
up.
ask if there are any other questions here before we did move on to the last subject, which happens to be Podman Desktop, so it's a nice segue.
Yeah.
All right. Given that, we will thank you, Urvashi, and Florence, and I'm not sure if Stefan or Florence is taking this over, so I'll hand it over to you guys.
Yeah, so thanks. Hi all. So wanted to give a little bit of update on Podman Desktop and the different features that we have been adding to the tool. So I'm just going to share my screen to show you a video. Sorry about that.
Taking its time showing.
Yeah. Apparently, macOS is requiring me to update my preferences, so I need to just rejoin. Sorry about that.
Okay, computers, you gotta love them. While we're waiting for that to happen, I'll just note that we've got a number of great questions going on in the chat in Blue Jeans here about Fetchit, and those will be included within the notes if you want to reference them later. On.
Okay, maybe before Steven join again, I can say that there is a new version of Podman that will come, Podman 4.2, and we are planning to cut a release of Podman Desktop just after the release of Podman 4.2 to be able to include the Windows installer and the macOS installer inside of Podman Desktop. So from Podman Desktop, we will be able to install on Windows and on Mac Podman 4.2. Yeah, Steven is still not joining, so
I'm here. Yeah. I'm just going to share my screen quickly. Sorry about that. some reasons I am getting challenged with BlueJean today. So.
I think next month I'm going to work on getting us over to Google Meet. We've been having way too many problems over time with sharing here. But now you're sharing just fine.
You see my screen now? Okay.
Yes.
Yes.
Good. So now when you start Podman Desktop, you have this home screen that is showing you the state of Podman, if it's running or not, and it allows you to start it. So once it starts, you can see your containers, your images, and as usual, if you start to pull images from the CLI, you will be able to see them directly into the list. You can also directly start the container, define its name, define the port mapping, if you need to do that. Once the container is started, you can directly open the application, or you can also inspect the containers, so you can see the logs. You can get a terminal directly into the container as well and see the different details of the container. You can build your container file if you want to do that, to create your image. Once you have the image, you can see it in your list and you can start it as well. You can still manage your Podman machine, so you can create multiple machines. You can delete them or adjust the memory if you need. If you have to work with proxies, you can configure that as well, and you can configure the registries that you want to interact with. So you can pull images that are private, of course. So once I am not authenticated, you will see that I cannot pull my image, and once the registry will be configured, you will be able to see that I can properly pull my image, which is private. Let's add the registry, just put the server, the registry URL. So here it's just Docker Hub. Now if we pull the image, we'll properly pull it. It's good to verify that it works. Then you can also interact with the registry by pushing your tag. You can see here that I have my image that is created on kube, but now I'm going to push it. And I have been able to push my image directly from Podman Desktop. You can also use a little bit of the Docker extensions. So you need to pull the proper image. So we have been getting requests for Trivy and for the OpenShift extension as well. So we have been running some tests to enable that as well. So I think that's it for the demo. The other points that I wanted to, sorry?
Well, one quick comment. Can you remove the letters DOCKER from the volume extensions there?
Yeah, we should be able to make something.
We don't need that adjective.
The
Or you have to put money in the Docker jar.
and so otherwise, yeah, I wanted to point out, sorry, that we are running an early adopter program. So for all users who are willing to contribute, to provide some early feedbacks, and to also help us shaping the tool, feel free to join. You will find you will find a reference to the program and a form on podmandesktop.io. So, for example, we will start to work on a grouping of containers when you run a compose file or when you run pod. So we are definitely seeking for people who will be interested by providing feedback on the UI and the UX that we will be working on. So feel free to join if you are interested. And the version which we just demo will be available along with the release of Podman 4.2. So that's everything we have. Any questions or feedbacks? I think, Tom, you are mute.
I've got to go off the mute. I was just going to say, feedback-wise, it's looking really great from my end.
Thank you.
Hey, any further questions? Oh, Dan?
I think I'm interested in how the scanner is working. It must be docking the Docker API to the Docker Podman socket?
Yeah, it's using the socket, yeah.
Yeah, it's very cool. Once we have this out, it'd be nice to go to them and say, hey, you want to advertise that Podman Desktop works with their plugins. I'm sure they'd be willing to do some joint marketing with us. Aquasec.
Right. Any further questions on Podman Desktop? Or for that matter, do people still have some outstanding questions for Fetchit or anything else that people want to bring up?
I think there's been a Fetchit discussion going on in the chat room. People want to read it.
If you have any further questions there, let Sally know or Ryan know or ask now real quickly. Those questions and answers inside that chat will be captured inside the meeting notes if you want to take a look at them later on as well.
Yeah, I had a quick question about volumes, and maybe this is a Podman issue, but it seems to me that the risk of like accidentally pruning a volume that you care about is pretty high, because since prune is kind of running asynchronous. Is there any protections for that at all?
Well, the protection is that you choose to run Podman prune on a schedule. But if you're worried about losing anything, you could log in and run it manually whenever you want to. It's as much protection as Podman prune provides. It's straight up that command. So
I don't think Podman prune by default prunes volumes. It prunes images, and you have to specify. I think you showed prune with a volume set to true. So by default, you would do it as false and just leave all the data on.
Okay.
Yes, I missed that part.
Yeah, I mean the only time Podman prune would prune a volume, anyways, is if there's no container that's using the volume. Right, so you'd have to remove all your applications that are using the volume in order to actually have prune affected.
I was just going to say an interesting thing. If you think about running Fetchit on an RPM OS tree based operating system, we were talking about rollback. There's a feature that when you reboot, it just goes back to its beginning state. So that would be like a hard reset. And that's the type of system that I envision Fetchit running on, is these, remote, maybe edge computing, single workload, few workload systems. In that case, we wouldn't have to worry so much about rollback, because you just blast it away.
I think you're underestimating the way the people will use this tool, so I don't
Maybe.
wouldn't make any assumptions about.
Yeah. Well, I also hope that the community takes off and people use it in all sorts of ways.
I think it's a very cool tool.
I think they will.
I think we don't have Matt on, right?
No, he's enjoying some well-earned PTO this week.
All right. So Podman 4.2 is going release candidate 3 this week, and hopefully shipping next week, I think is the current schedule. Do you have any further update on that? Do you have actual dates, Tom?
August 15th is our date for shipping it out to Fedora. I'm not sure where that is date-wise, but that's a week from this coming Monday.
So anybody that's out there, try to play with the release candidates and give us feedback before the 15th, or else it's going to go out as is.
Just want to make a note of that for later so I don't forget about that. Okay, any other questions or topics that we want to talk about before we wrap up here? Right, and I will say that our next meeting for the community meeting is on October 4th at 11 a.m. And then our next Cabal meeting is coming up in a few weeks, or a little bit more than a few weeks. Actually, I've got September here. It should be sometime in August. It should be August 15th. My notes are wrong. I'll have to double check the date. Don't hold me on that date, but it will be in the middle of August for the Cabal meeting. And with that, I'd like to thank all the presenters and all the people here participating today. It was a great meeting and really good to see. And we'll see you all next time.